Okay, I'd like to introduce to you the 336 hybrid from Caterpillar. It's right out in front of us. Okay, what we have up on the bench is our standard 336E. So we've got that machine there for reference for you. We've been talking a lot about comparing and contrasting the two different machines. And I think one key point here that we talked about earlier is those machines look very similar to each other. In fact, other than the decals on those machines, if you look at those 236s, they are nearly identical machines. It's really about what's under the hood. The hydraulic hybrid technology that's at work and really enabling that machine in front of you to be saving 25% less fuel compared to that machine up on the bench. So now, if you think of the pipeliners out there, or sewer and water contractors, or maybe even some bridge work where they're just pulling material out very close to the hole, minimal swing angle, trying to move as much material in the shortest period of time. Even in this application, folks, and this is key, we're seeing a significant amount of fuel because all three parts are still working together. Even though the magnitude of the swing is not near what it was in some of these other applications, anytime that machine accelerates and decelerates to dump that load, basically on the swing brake, there's opportunity to save oil inside that accumulator and then release it at this point when he's going back to the hole. It's more about the intensity than it is the amount of swing angle.
I'm curious, which was the bigger engineering challenge, the hardware component or the non-hardware component, I'll call it? I could call it hardware and software, but...
Yeah, it's a good question. I'd say each one of them has its own challenges, but really the important thing is to appropriately size the system and appropriately design components that will allow you to have flexibility to design software that will maximize your savings. So that deep integration, deep vertical integration that is important in these type of systems, because we said we count on three pieces. We count on the engine and pump, we count on the main valve and restriction management to the main valve, as well as the energy capture and reuse. So putting something like that together and managing the power, making sure that the performance is not compromised is really the key, and that's what I call that vertical integration. So each piece has its own big value if we wanted to accomplish what we did.